With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. So this question is basically related with the question which we have solved regarding the terminal velocities. So here it is given that there are forces which acts on a body. So from here the question basically start. Let's say we are having a sphere. Okay, so there would be forces which would be acting on the sphere. One would be the downward force, which would be equals to mg. Okay, and one would be basically it would be having a velocity. So one would be a force which would be resistive to the velocity. So if it is velocity in the downward direction, the resistive force would act in the upward direction, and it is given as to be b into v. So we said that b into v. So that means resistive force is proportional to the velocity but acts in the opposite direction to the velocity. Now if it is submerged in a liquid, so there would be a buoyant force. So in the earlier question we were neglecting the buoyant force, but in this expression what is given, now if the buoyant force were also taken into account, then the value of the terminal speed would be what? So buoyant force, we know that whenever there is a liquid any object which has been placed in the liquid, so there is an upward force which we call the force to be buoyant force. Okay, so if we see what is the net force on our system, so F net, this would be equals to mg minus Fb, which is the buoyant force, minus Bv. Okay, now there is also a term which has defined in the question, and that is the terminal velocity. Now terminal velocity represents the velocity at which the acceleration becomes zero. Okay, terminal velocity is the velocity at which acceleration is zero. Now we know that net force could be written as mass into acceleration. Now if you don't know, then also it is given as to be here. So net force is written as to be mass into acceleration. So we say that net force could be written as mass into acceleration. This would be mg minus Fb minus Bv. Now when acceleration equals to 0, then our velocity would be called as the terminal velocity. Now if we take buoyant force into account, then the terminal velocity would be increase, decrease. So decrease, increase, remain same, or increase or decrease depending upon the density. Now from this expression we can say that our mg minus Fb minus Bv t equals to 0. When the velocity is terminal velocity, acceleration would be 0, so this term would be 0. So from this expression we can get the value of the terminal velocity, which would be mg minus Fb divided by b. Now here we can see that if we take buoyant force into account, then we will be subtracting something from the numerator. So this would decrease our numerator. Now if numerator is decreased, so our velocity, or we can say that terminal velocity, would be decreased. It is clear from this figure, from this expression, we are using a negative term here. It would be a negative. So that means numerator would be decreased. Therefore, terminal velocity would be decreased. So A would be the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.